Okay, Software Engineering Lecture 2, Developing Requirements. So I know it was an entire week ago and you guys had a vacation. Well, some of you may have had a vacation. Monday was Memorial Day, so hopefully you were enjoying yourself. It wasn't, the weather wasn't so good around here though, so maybe you found something fun to do. But anyway, most of you probably forgot what software engineering is all about. Maybe, I don't know. So I'm going to review a little bit as I go through lecture number 2. We're talking about the first stage in the development process, or requirements. And before requirement stage, we may actually put together maybe a feasibility study at the beginning. So last time, if you missed, this is your first class meeting and you missed last week. Last week I went over the entire format for the course. Also covered software development lifecycle models and the processes and the phases. And then I started in with lecture number 1, which went over sort of the models themselves. And we looked at spiral, iterative development, rapid application development, waterfall model, and some of the different design techniques. So today we're going to really look at developing requirements. And if you remember last week, I also talked about forming teams. Actually, I guess we covered a lot. Picking a topic, sending me. I don't have any emails. I didn't get any emails from any students. That's okay. Maybe you can put it in the EMS though. Once you decide, you kind of want to document it so you remember who's on your team. If you haven't picked out a team yet, you have an opportunity at every one of your class meetings to speak with people sitting next to you and say, hey, do you have a team? And if you want to work in a team. Otherwise, you can work on this project by yourself. If you work on it by yourself, you get the same grade. There's no reduction or anything. But you have to do 3 times as much work, 4 times, depending upon how many team members you have. And if you have 3 or 4 team members, you split the work out, and then everyone does something, so it's more work if you work by yourself. The only problem is you might prefer that, depending upon how often you might come to class, how often you might see your fellow classmates. It might be a preference for you, but there's no harm done in that. So once you form your team, and let's say this is a real-world software development project, and you've got your topic. Usually, we looked at it. The concepts of that and what we were covering last week, and we also looked at the types of projects. So you're going to develop something that's going to basically take a year to 2 years to build, and in doing so, you're going to follow this methodology. And methodology normally starts out, as I mentioned before, with a feasibility study, and sometimes we refer to this concept that's written on the slide here, the domain analysis that might actually occur. So in order to come up with your first deliverable, which is your requirement specification, you've got to do some domain analysis in order to figure out what it is we're actually building. Because fortunately for you, you get some variety. If you're a software development company building software packages, usually you have some sort of a choice in the topics that you pick, but you're software engineers. You're not mechanical engineers, you're not working as a mechanical engineer, electrical. You may not know anything about air temperature controllers, flight simulators, and all these other technologies that you're building software for. So the domain analysis is basically the process by which a software engineer learns about the domain and understands the problem. So someone comes to you and says, hey, I need an air temperature controller built. Well, you're probably going to hire someone who knows something about air temperature controllers. Maybe. Maybe they don't know how to build the software for it, but they might know something about the technology, which is basically what you're doing. So the domain, by definition, and there's a lot of terminology in this lecture set that I'm basically going to cover for you today. So the domain is the area, the field of business, the technology, something that the client will use the software for. So if it's a railroad application, the domain would be the railroad industry. Heater control, air conditioning industries, different areas in the business market. So that word domain is pretty generic, used a lot in English for some reason well, I shouldn't say used a lot, not in common every day. Nobody ever says, what's the domain? People look at you funny. It's like more of a software engineering term, I would say. And the domain expert is the person who has the deep knowledge of the domain. So sometimes you might actually be involved in what's called a joint application development or a JAD session, because you're not going to hire a domain expert to work at the company. Instead, you're going to bring one in, give them a nice dinner, hotel night stay or something, trips to the Sharks game or something. Bring him in, hold him for a couple hours, and pick his brain. or sit down with the domain expert along with a couple of the engineers, along with people from other fields, and sit there and say, well, what do you think of this idea? And what do you think some of the problems might be? And then you can accomplish a lot, essentially, in terms of grasping and understanding what this project's going to be about. Because if you don't understand what the project is about, it doesn't really matter how well you do the software engineering process, it's not going to work for you. It's always going to fail. So we have different starting points for different projects, and this grid is actually kind of interesting because, hold on one second. Forgot about my little timepiece here so I can watch how much time I'm talking. Okay, there we go. So you guys don't miss your lunch. All right, so we have A, B, C, D. So that's not a high math grid. It's pretty simple kind of. But it actually kind of just points out the starting points in the most common areas. Everything is going to start at one of those quadrants. And for your particular project, you've got some choices. You could do a new development, or you could do an evolution of an existing system. So they usually refer to this as evolutionary system development because you're evolving the system from version 1 to version 2 versus calling it a new project when the system doesn't exist at all. So you might actually, as a group, decide to pick a topic that's an upgrade to an existing system. You go through the same software development process, same steps, same format, but you're using an evolutionary type of environment versus a brand new. And you're either going to have the requirements that must be determined, or the client is going to actually produce the requirements for you. In your particular case, I'm not going to produce any clients. I mean, I'm the client. I'm not going to produce any requirements for you, so you'll have to put that together yourself, which means you're going to be in either A or C. In the real world, we've got B and D to consider, where the client actually hands you a requirement spec because they hired another software engineering firm, let's say, and they put together a requirements doc. Or maybe they went through the feasibility, they put together a requirements doc, and they didn't have the funding or something, so they waited. Or maybe they're borrowing the requirements from another project, and they're saying, build me one just like this, or something. So you might actually have that already in existence at the starting point. After you come up with the requirements doc, the first section, after you come up with the idea and you're developing the requirements documentation, the first section of the requirements is going to be the scope. It always starts out with an introduction, slight description of the project, and then we lead into the scope or the problem definition. Interesting thing, you'd think that this would be a no-brainer, but we have problems that come out. One of the most popular you probably have heard of is called scope creep, where this project never actually finishes because nobody ever reads the scope or follows the scope. And the interesting thing about the requirements document is this is your contract. If it's not in the requirements, you're not building it. If you said the scope was version 1 to include features X, Y, and Z, features A, B, and C are not in there. So somebody in the management team or the project development team should put their foot down and say, hey, wait a minute, this is X, Y, Z, this is what the requirements doc is for, and then that prevents scope creep, which is a common problem. Or you go back and you change the requirements doc to include extra stuff. Because if you think of the concept, you start out with a to-do list, you can organize it. You could put a priority on the different items on the to-do list. You can schedule the time, and if you're really structured, you can actually complete everything according to what it's supposed to be due. If things just keep getting added to the to-do list, it happens every day in life. Nothing ever stands still. Well, nothing ever stands still in a development project either. The requirements always change. It's just a fact of development that happens. So the problem itself needs to be expressed at the beginning. It might be expressed as a difficulty the users or the customers are facing, or an opportunity that will result in some sort of a benefit. And the solution to the problem normally will entail, hopefully, the software development, or developing some sort of software. So you could say this is version 1.0 of the Acme registration system. And this version of the system will provide users the ability to drop classes. And then that is a very specific problem definition. So if there's anything about adding classes or changing classes or anything else outside of dropping classes, it's not part of that document. Because the interesting thing is you get this really nice scope, and then you start reading through the document, it's got features about adding classes, features about changing classes, all sorts of different things that never really belonged in the system to begin with. And then you run into the problem of, we charged you $10,000 for the system, but you're asking for more features, but they're in the requirement spec, so you have to give them to me, but it's going to cost me more than $10,000 to make all this stuff. So usually a requirements doc is very closely tied to the payment system, to what it is you're actually building, what you're supposed to get paid for, what you're going to validate and verify at the end of the project. Here's some examples of narrowing the scope, because what you really want to do is narrow that scope. The larger the scope, the more stuff you're building. The more it's going to cost you, the longer it's going to take. So you want to narrow it. So narrowing the scope, you can define it by redefining the problem more precisely. So you're still building the same system, but you're specifying out different components of it. So you can list all the things that might be, or you might imagine the system doing, and exclude some of those items to make it broad, or you can determine high-level goals to make it narrow. And the example on the bottom of the slide is for a university system down here. This one is the big chunk at the end here, which we got everything. So a list of all of everything, which would be very broad. When we say we're narrowing the scope, it means we're taking and we're saying, well, this is the scope of another system, this is the scope of this particular system, and we've pulled out features. It's probably too far away for you to actually read what's on that slide, but it talks about features of a university registration system. This in here says browsing courses, registering, paying fees, and this says room allocation, exam scheduling. This all is in here. Exam scheduling, room allocation, registering, all of it would be in there. So it's basically just breaking it out into smaller components. They actually call that, in terms of the development process, it's called function decomposition or functional decomposition, because you're decomposing the system into different functionalities. And you can start out right there with the scope and functionally decompose it and break it out. Makes it more manageable. The theory, it's easier to solve the smaller problems than if you concentrate on the big picture. You can't see all the smaller details when you're looking at the big picture, which is why your scope's important. So after you've defined the scope, the next part in the focus of the requirement specification, as you might expect, is a list of requirements. It's nothing more than a huge to-do list. It's kind of written out a little differently, though, than a regular to-do list. It is broken out line by line with requirements, and the requirements are short sentences. And in the course notes at the end of today's lecture, I'll bring it up and I'll show you again to remind you, because if I keep showing you the templates, it kind of reinforces some of the points in terms of what you're doing. As a team, what you're going to do is come up with a bunch of these statements. So by definition, this requirement is a statement about the proposed system that everybody in the group that's going to accept this system, which would be considered the stakeholders. Another new word perhaps for you, maybe not. Depends on how much exposure you've had with business. But a stakeholder is anyone who has, it could be a user of the system, could be the owner of the system, could be anybody, client. They must in turn must be true in order for the customer's problem to be adequately solved. So if you don't know what the problem is, you haven't defined your scope, how are you going to define requirements for it, essentially? So all of the requirements relate directly to the scope, and all of them are necessary. So you shouldn't have anything in there that's not necessary. But we have two groups of requirements. We can break them out into what's called functional and non-functional. I'm going to talk about that in a few minutes. But at the point we're looking at, we're writing things that have to do with functionality, whether or not they're directly a needed piece of the system that has to be in there in order for the customer's problem to be solved, or it's a cosmetic related thing, or it's a feature of the system, which kind of gets into that kind of thinking, well, what's functional, what's non-functional, and I'll go over some examples in a few minutes. But the pieces themselves are short and concise pieces of information. They say something about the system, and all stakeholders have to agree that they're valid, and it helps solve the customer's problem. So the collection of the requirements is this requirements document. So we call this requirements document. It's not a paper, it's not an essay. It's a collection of requirements. And here we have our functional and our non-functional. So to start out with, requirements is going to tell us what the system is going to do. After we get done saying what we want to do, the design document says how we're going to do it. So everything is focused on, in terms of requirements, is what are we building? How, not how, but what. So when you write and you think about the requirements, it's like trying to describe your house as an example. It's got 3 bedrooms, 2 baths, or 1 bedroom, 1 bath. It's got one window, 2 windows, I don't know, 1 floor, 2 floor. Some of those things, if you were to build this thing, say, hey, I'm looking for an apartment, this is what I need. It's got to have 1 bedroom, 1 bathroom, one kitchen, all these things. Those would be functional. In order for that apartment to function, to solve the customer's needs, it needs a bathroom. I'm not going down the hall to use a bathroom. I'm going to want it right there in my apartment. It's going to need a sink, a shower. It's going to need all these things. That's a functional requirement. Does it have a view of the city? Non-functional. You can still live in the apartment and do just fine without a view of the city. Does it need heat? Some people might consider that a functional requirement, some might not. So there's some judgment that's made between what would be functional and what would not be functional. And this is actually just going along, and the same concept is sort of used in a lot of different other disciplines outside of software engineering as well. A chair must have 4 legs to be functional. Sometimes people build chairs with 3 legs. It still might be functional. It depends on the design of the chair. Does it support you, or does it collapse? It has to support you. Everyone would agree a chair is not going to function as a chair unless it supports body weight. But is the chair made out of wood, plastic, paper, nylon? Non-functional. All right, so functional is what the system should do. Non-functional are any constraints that might adhere in the development environment. So taking this to a software engineering perspective, we say that we need a password field, let's say. So we need a login name and a password field for our application because we want to provide security. That would be a functional requirement. So non-functional might be when the user types in the password, it has to show asterisks on the screen. Or that password should be 7 to 10 characters. Or something about characteristics, the color of the password, the color of the screen. I don't know how big the font is. It might be a non-functional. So anything that's not critical. So both of the two are actually put into the requirements document because both are sort of equally as important. If you think about software in general, the customer always judges the entire functionality of the system upon its non-functional features. Who else would use Microsoft Windows? I'm just kidding. That was a low blow. Otherwise, if it didn't look as good as it did, right? It's not really functional. But all the non-functional stuff works great. So, actually, current versions are better. So, all right, so what are some other types of functions and functionality in terms of the functional requirements? Well, what inputs the system should accept? What outputs will it produce or should it produce? What kind of reports? And the inputs and the outputs are not necessarily associated with reports or passwords or things. It might be with a data exchange from another system. It must take the receivables from the accounting system and print out invoices or something. Maybe it's a reporting module or something. And then what data the system should store and other systems might use, what database kind of support it might have, what features to collect data if it's not even using a database. The data might be an input, might be an output. What computations is the system supposed to perform, what calculations, and then timing, synchronization of all of the above. What order are these activities supposed to occur in? The password is before you log in. The computation is after you log in, something of that nature. So here's some examples then of non-functional requirements, where we have 3 main categories. The first category is reflecting, and this is, if you ask anyone how do you judge a software package, going back to my comment I made on user interfaces, it's usability, effectiveness, reliability, maintainability, all those different features. So you see on the top here, these are some categories reflecting these particular best practices of user interface design and software development in general, those are really non-functional. If the system is not maintainable, it still functions. How long is it going to function for? It may not necessarily be as long as if the system was maintainable, but that would be a non-functional requirement. Another way of approaching this, is it functional or non-functional kind of question, might be, if I didn't put the feature in, is the system still going to work? Yeah. Or am I solving the customer's problem with this requirement? If you're not directly solving the problem, it's non-functional. Who cares if something is reliable? Well, that might be functional. And actually, that brings up a good point. Let me use another example before I go into that. What about the maintainability, going back to that concept? The function of being maintainable is non-functional to a user whose scope says we need a system that is going to do X, Y, and Z. If it does X, Y, and Z, you've solved the problem. If you're writing software that's going to be used on a heart monitor, and it's going to be controlling someone's respiratory system, I would say it has to be reliable. I would say that that would be a functional and not a non-functional requirement for that particular system, which kind of breaks the categories. So what I'm telling you is not set in stone. This list doesn't tell you, oh, if it's reliability, it's always non-functional. Not for a heart monitor, not for a fire alarm system, not for something that's emergency related. Reliability, you want the sensors to work. Otherwise the system doesn't work. It's not functional in that perspective. Now, if it were, let's say, a heater control unit and it wasn't reliable, the user just goes over and ups the heat. How many times have you done that in a hotel room? I just turn it to the maximum because it's not getting hot in here. It's not reliable because somebody tweaked it so the customer couldn't turn it up or something because they don't want to keep paying the electrical bill or something. I don't know. Many different things happen. So anyway, I'm not going to go through the whole list, but these are some examples of categories of items in this particular category, or examples of things in this category. The next category might be the environment and the technology of the system, the platform or the technology being used. If I wrote the program in Java versus .NET or something, it's non-functional. The program is still the program. The platform that's running on is going to not necessarily be part of the scope of the project. We need a student registration system. But as an example, it can be written in Java or .NET or on the internet, not on the internet. We have many different platform choices these days. It could be a mobile app, it could be an iPhone app, it could be a Google app. But if I said that in my problem scope, I said that this is a customer registration system that works on iPhones. And I put a non-functional requirement in there, and I said, well, let's make it work on Google. It's not meeting my scope. So even though these are non-functional, they still have to be in line with the functional. They still have to be in the scope in terms of what it is we're asking for. Another one might be project plan and development methods. You might say, well, we need a project team of about 5 people. Let's say 4 people have to be working on this team. That's a requirement. That's an example of a requirement. So it would be a requirement that it had to be built on .NET or Java. These are all requirements, but some of them fall into different categories as I'm showing you. So non-functional requirements, here we have product requirements as well, in terms of performance, reliability, portability. Organizational requirements, delivery time, you can stick in the requirements doc, hardly ever see it. Something where it has to be delivered in 30 days. Let's say you were coming up with a requirements doc to fix a problem with the year 2000. It would have to be fixed by the year 2000, right? Midnight of 1999 or whatever. So that would be something you'd stick in the requirements doc. Other than that, or let's say it's a Christmas application, well, it's got to be done by December 25th. That would be a requirement that you'd put in there for appropriateness, but it may not necessarily be in there for 90% of the 99.9% of the cases because it might not apply. Also, something about the development team may not apply either. Depending upon, it has to be built with using our own developer. Okay, we have our in-house custom programmer, and he's the only guy we trust writing software for our company. Let's say you're working for the Department of Defense. This actually might be the case because you have to have programmers that are security clearanced, let's say. So you might put in there, and these are non-functional requirements, but they sort of borderline on function, if you think about it, because the system can't be written by a non-certified, non-approved programmer if you're working with this contract. Any external requirements, legal requirements, interoperability, stuff like that. If you're writing a retail sales program, shopping cart must be able to handle sales tax so the customer can charge it, stuff like that. Here's some more examples. And now we're kind of splitting hairs. If you haven't noticed already, something that might be functional to one person might be non-functional to another. And it may also be project by project, depending upon. So it's sometimes a judgment call, and it's also sometimes a project-based call, which is why you'll never see in real life a requirements doc broken out into functional and non-functional. And let me tell you why people actually do this in real life. You'll see this by Acme Inc., software development company, who's working on their first project ever. And then someone learns about functional and non-functional. And they go, oh, wow, great, we'll just divide it out. So the first part of it's all functional, the second part of it's all non-functional. Because they're working on their brand new software development company's never done this before, they're working on their brand new first project. And they're on borrowed funds, they borrowed from a relative, they paid for all of their expenses, and they start working on this. And then they figure out, oh, well, we don't really know what we're doing. They go through the analysis process, they come up with a design document, and then they run short on time. Because that happens with professional software companies working on their 100th project. Will always run short on time. And then they run low on money. And then they run out of funds, they run out of time, and then they quickly scramble and put something together. They and this happened a lot actually, it still happens, they like the fact that it's broken out because you can clearly see what must be put in, and then they leave out everything else. So if they have all the list of functional requirements, and they got that list down, because eventually someone will have to take all these requirements and go, well, we're short. Now it's crunch time, and we only have a week left, and we only have half the system implemented, and we don't have any money left. So we got $10 to pay this guy to work for another hour or something. I don't know, $100 maybe. I don't know. What features can you put in? This is, oh, it needs to do this, it needs to do that. So it's easy for the amateur company to look at the functional and the non-functional and focus on the functional and then deliver part of the system and then say, hey, we're working on the non-functional, the color of the screen, we're going to fix that. The logo, we'll fix that. This will fix that. So that they can pass it off at the last minute. That's why people like taking the requirements doc and separating it out that way. In real life, you're setting yourself up for disaster when you do that anyway. But because you're already thinking you're not gonna do it correctly and you're gonna run short. If you think positively and say, hey, yeah, then you're gonna divide it out by feature, which is what your template's gonna be looking like in terms of what you're looking at on page 25 of the course notes that I'll visit at the end of this lecture. We're not going to use functional versus non-functional because first of all, it's really hard to determine what fits into each one of the categories. Second of all, we're going to go through and we're going to be professional and we're going to do proper analysis and we're going to come up with a proper design document. We're not going to have a problem. We're not going to run low. We're not going to run late, and we're going to be on within our budget. Everything's going to flow correctly. So here's some examples of the non-functional requirements. If we said we had versus functional, if I say talk about privacy as an example. So the functional requirement might be that the usage data for the management of the system, we have to save the data, let's say for the system management of some sort. And the non-functional might be we can't identify individuals in the data, which means we can't use their social security numbers, their addresses, or their telephone numbers or something. So you can kind of break out and say, we have this feature called privacy that we're implementing, and then we can break out functional, non-functional. So what we end up doing is feature by feature, we list out both. But we don't have to say, this is a functional, this is a non-functional. Why would we bother? Because we don't care about that. That's why we haven't broken the entire document out that way. But you want to include both, is the point. So another thing might be minimizing records here. A functional one might be we have to retain all the records, a non-functional discard all the other records. It doesn't really matter if we don't discard them, it's still going to work. So that is essentially the task that you're going to have to go through in terms of developing those requirements. So what you're going to end up having to do is, after you've scoped your system, then I would actually come out with a piece of paper, sit down with your group, and just start listing what features do we want. List out and make a list of the features. And then take the features and then sort of like an outline. And each one of those features has subcomponents to it. As an example, it must have a login screen. Okay, so we're going to have a login screen. That would be a nice feature to the program for security purposes. Well, what's going to be on the login screen? Well, it's going to be a small pop-up window. Or it's going to block the usage of the application, or it's going to come up at startup, or right after the splash screen or something. And it's going to have a name and password plus 3-digit, RC code or something, or remote, key fob code or something. Or it's going to use this, or it's going to use that, or fingerprints. It's going to take a fingerprint scan or something. And you start listing those out as sub-items. And that actually kind of turns into your rough draft. And then you take those items and you make sentences out of them. And say, the system will have a login screen. And that's like Roman numeral A. The system will have a login screen. And then numeral A.1. And you make an outline, it's a full sentence outline essentially. The login screen will come up before the application is available, or right after the splash screen. And then we have A1.A. So we indent a little bit, and we increase the numbering down a little bit, and we say, the splash screen will come up for 2 seconds. And then we have 1A.2.A or whatever. We go down further, and we say, if the splash screen, if the user clicks on the splash screen immediately, don't wait for the whole 2 minutes, bring up your login screen. And you're going down into a minute level of detail, which sounds ridiculous when you think about it. Some people go, why? Why bother? Just say, login screen. Well, the closer you get to the real implementation details of what it is you actually want, the better you describe it, the better you get it, in theory. So this particular requirements document is probably the most important document of the entire development process. More important than the implementation, because it's outlining what it is you want them to build. All right, so some techniques for gathering and analyzing the requirements, because here's what's going to end up happening. You've developed this concept, and you're going to build this product. So now you got, well, how do I get it? Well, for your particular case, you're just going to sit down there and then do what I just said a minute ago, and probably take out a piece of paper and just start brainstorming. What features do we want? And then for each one of the features, spec out, what should that have? What kind of help system should we put on there? And you have a whole list from a brainstorming session, probably. In the real world, what the developer wants and what the customer wants are two different things, usually. So they rarely match up identically. So the software development team actually has to pry it out of the customer. Most of them don't want to spend their time. That's why they hired you. They don't want to sit there in meetings and tell you exactly what they want. So the amateur companies, they make the customer tell them everything. I need to know exactly what you want. Like, why don't you just build it yourself then? That kind of thing. All right, so observation and interviewing are probably one of the most important things a development team does. And this is why software engineers actually have to be people persons, whatever. They have to be able to communicate well. So it helps to be able to relate to the user, go out, meet with the user, observe the user. So what a lot of software engineers do is they have one guy on the team, one of the project team that works right at the beginning, who doesn't do anything but solicit requirements. So the guy goes out and watches one of the bank tellers. And let's say he goes to the bank, spends a day at the bank, and watches what everybody's doing. Says, well, the bank teller she's got 3 systems sitting in front of her. She uses this one for this, and he makes notes and says, well, she's using that one for that one. And then the bank who originally hired you to do this project said, hey, we want to make things faster. The tellers are too slow. And that's the problem you're solving with this new teller application that you're putting together. by observation, you can actually kind of say, well, what is making it slow? And then you build the requirements to solve those problems. You say, well, we only need one system, not 3 systems. There's no reason why this system can't talk to that system. Why are there 2 different databases? There should only be one. And you consolidate, and then you work on the feature list. What is this system after we consolidate everything? What are the features they're using, and what are the features they're not using that might actually be causing some slowness in the system or something? And maybe it's a networking issue. Maybe they need wireless scanners or something. And actually, people, you guys are familiar with that Chase commercial. You take your iPhone and you scan it over. That's faster than going to the bank teller. If you think about it. Bank teller's got to take the check, put it through the little thingy bob. She's always typing and doing stuff. How come you just scan it on your iPhone, click a button, and it works? Anyway, so sometimes it's the process of the business tasks that are being performed that need to be analyzed. So in terms of the observation, they might also read documents and discuss requirements with the users. So the observation might be interactive as well, where they would go out and say, what do you not like about this? How can we make your life easier? Shadow important potential people, ask them to explain everything that they're doing, which, you're going to get those guys to do. And maybe videotape. Record the session or audio record the session. If you audio record the session, then you have a history. Because what ends up happening is you go back and you talk to the bank manager. He says, oh no, our tellers, they like the system. This is what they like about it. Because he's got a different impression in his mind. And then you play back the recordings. I hate the system. I hate the system. I hate the system. You go, look, this is what your people are saying. So it kind of provides a little background, because what ends up happening, you asked 100 people, if you come in here to ITU and you ask random people, what do you think about the EMS? Depending on who they are, what job they have, how long they've been, they may have different comments. And then ends up happening is you start asking, well, what would you like in there? And all of a sudden it's overload. You get this group that wants that, this group that wants this group that wants this. It's hard, you can't please everybody. And then the manager who wants totally something different. So you have to actually sort of do some analysis on the observations to come up with, statistically, 90% of the people love this feature, we're going to leave it alone. It's only that 10% loud group over there that hates the feature. Okay. So you can also do interviews where you can, or surveys. Actually, that's what they did here. They sent out a survey to students to say, how do you like this particular feature, this particular service? How do you like that service? And then you tally up the scores and you come up with some sort of analysis that will essentially tell you, again, how important something is versus something else. You might look at alternatives. You might also look at different sources of information. You might also be drawing some diagrams or something and showing them pictures. Diagrams or even prototypes actually work. So there's, I don't think I have prototyping in here. I have brainstorming next, but I know prototyping. Let me talk about brainstorming, and then I want to briefly mention prototyping, because it's coming up in a future lecture, but it makes sense with requirements as well. And what I've been talking about so far has been related to the concept of brainstorming. So when we brainstorm for something, we're getting a bunch of people together, whether they are the end users, the managers, and we're asking them for their opinions. We're recording it, or mediating it, or monitoring it. And then what ends up happening is a side effect to this, and you can kind of read through some of the different characteristics and features that are on that door. There's a lot of people talking. Could someone do me a huge favor and shut the door? That will prevent people talking over me in the background. Thank you. All right, so you can read through on the slide here. We've got different characteristics about how to put together a brainstorming session. But let me tell you the pros and cons over this, and also compare it to prototyping. So in terms of the brainstorming, once you get people involved, then they have an interest in it, and then they like the system, because they know that you're taking their comments into consideration and you're using their feedback, hopefully. So on Monday morning, when the bank tellers come into the office and notice, or to the branch, brand new system. You have acceptors and you have rejectors. You'll have more acceptors if they've been part of some sort of a brainstorming, even if it was a survey. You know, so for example, here they sent the survey out to students. And what do you like about the TAs? Or what do you like about the registration process? Or what do you not like about it? And then when the user finds out, oh, look, they changed it. Oh, cool. Oh, look, they used my idea. Yeah, you know, then there's a positive reinforcement of it, and there's more acceptance of what was changed. When you don't involve anybody and you just change things overnight, and the people come in and they go, it's the first reaction, and this is the psychology. First reaction is, oh, forget it. I don't know. They never told us about this new system. You know, and half the morning gets spent rejecting the system instead of actually helping customers. Because they want to, oh, you know, I like the old system. Because some groups of people are not accustomed to change. You know, if someone says, we're going to change your schedule this week, and people don't like change. It's a negative. So, you know, they're going to waste time on purpose to prove that the change wasn't needed or something. Or, you know, anyway, long story short, it's twofold. If you gather, you analyze together as a group, you involve people, even if it's a small group of people, you have to monitor, you have to mediate it, you have to observe it, you have to document it. But long story short, it actually proves nice. Oh, my prototyping was in here. Okay, good. I'm like, I wanted to talk about prototyping, but I couldn't remember if it was in here or not. Let's talk about prototyping. So prototyping is used a lot in software engineering. In fact, you're doing it in your development projects, and you're going to do it about the same time that it would normally be done when you're using the prototype for the implementation. So a prototype, and I have an entire lecture on prototyping later on, but to give you some information that's related to analysis and to requirement specifications, which is why you need it now, sometimes you might not actually know what the user wants. So they say, well, we need this new system, it's going to be a foot mouse. Oh, okay, and the foot mouse is going to be used, or let's not talk about feet, let's talk about heads. Eyes is going to be an eye mouse. There's actually one on the market. Well, I don't know if it actually made it to market. It was on the last CES show. They had this pair of glasses you stuck on, and I don't know how the technology was working, but when you moved your eyes, it moved the mouse. Nice. It was actually kind of cool. Only problem is how many hours do you stand there staring at the screen? And what if you look down on the desk? Where's your mouse cursor? It's gone. So they put together this prototype system, and one of the biggest things that they found as a problem with this is, and you might notice this, those people using a computer right now, you know where your mouse is normally. Now you're working on an application, let's say you're in Word. You put the mouse in the document area. When you come back to that, you expect it to be there. So with this system, this prototype they put together, they discovered that the mouse moves, so they got to have some control to lock the position when the user looks away to go look at something else. Otherwise, it was too... Long story short, the interface was too much of a problem in terms of the control. Nice concept, but didn't work. So that was more of a proof of concept type of prototype that was put together to elicit requirements for what the system needed to do, and they discovered that the requirements needed to make this thing functional were limited. Like, you had to have something to control it, you had to have something, and that was just one feature that ended up with a problem. Some people had glasses, you know, and they needed, you know, and the glasses affected the ability of the mouse movement. Some people didn't have perfect, had wandering eyes, didn't have perfect eyes. Long story short, it didn't work with everybody, and then it had some features, and then they used it, however, to come up with a list of requirements that would actually be needed by observing people using this thing. Another thing that's very popular, especially in California, are focus groups. You put together a prototype, and you give it to a group of people. You put together a table of 10 people, and you put a couple of the prototypes out there. Let's say it's a toy of some sort. And you watch people, the people leave the room, they have the two-way mirror, and you watch people using the prototype. Let's say it's a bunch of babies, and it's a toy, and the baby's sticking it in the mouth, they're swallowing it, they're using it all in the wrong way, and then you go, oh, that's dangerous. Oh, look at that, they're sitting on it. Oh, look at, they're doing all this stuff to it. And then you can kind of figure out, well, what do we need to put on here? Huge warning label. We have to put this on here, we have to put that on there. And so, going back with the same concept as the headgear, it's eliciting requirements that didn't exist. So, another scenario happens with prototypes as well. The user comes to you and says, we're going to build this foot mouse. I want this foot mouse because we are tired of carpal tunnel syndrome in our bank, and we want everybody to use feet. Okay, so they come in and give the team a bunch of requirements, and they put together a requirements document, and then they build the prototype. So the prototype came second. And then they give the prototype to cut. Is this what you want? Look, you got to take your shoes off. You got to go like this. And you just go, no, that's not what we want, but that's what you asked for. Or sometimes you come back and say, well, this is what we heard. This is what we envisioned. And is this what you told us? Because the biggest problem with requirements is the customer comes to you and says, I want this, this, and this. And you hear that, that, and that. And you have to go back and say, wait a minute, you know, and if you start building that, and they really wanted this, now obviously you can see there's going to be a problem. So the simplest kind of prototype is a paper prototype. And when I talk about prototyping later on, we have different fidelities. So it's usually referred to as a high fidelity or a low fidelity prototype. And the fidelity is a common term used to describe the type of technology. So a very low fidelity kind of thing is a paper prototype where we've got, you know, pieces of paper. So a set of pictures maybe showing the users the sequence to explain what's happening. You know, here you have to insert the disk, you have to press this, you have to press that. And you can make sure that the requirements are correct. And the most common is a mock-up of the system's UI, the user interface, because that's all the users actually get exposed to. They don't really know what's underneath the hood. It's kind of like when you look at a prototype of a car and it's just the body, like the engine. There's no engine in the car yet. So you could write it can be written in a rapid application language. It doesn't have to normally perform any of the computations. Many prototypes are particular aspects of the system, but not the entire system. So it could be prototyping the control of the eye movement. Can you blink? Blink 5 times to stop it. Blink 2 times to pause it. Move it 1 time. Double move. You know, all these other motions you have to do, and then wear a neck brace at the end of the day because you have a stiff neck. More on use. Well, I'm actually before I have one or two more comments left on prototyping before I continue, but current rapid application development. Which, if you work, let's say, does anyone here work at Google? Yahoo? Google? eBay? eBay does this too. All right, so the rapid application development environments, or RAD environments, use prototyping as the development methodology. So let's go to Google for a second, because everyone's familiar with Gmail. Right? Gmail's been around for years. However, when it first came out, it was a prototype. Didn't do much. In fact, it's still a prototype. So they started with the prototype, they put it out on a website, on their web browser, and say, hey, look, mail. Sign up for a mail account. Everybody signed up for Gmail. Well, the early adopters all signed up for it. And it didn't really do anything. It had IMAP capabilities, but it didn't actually have the address book. It didn't have any of the features that it has today. They used the prototype with comments from users to create the application. And so users said, oh, I like threads. Oh, I like this. I like that. And they adapted the prototype to build a product, which is what's referred to as rapid application development. So they skip the requirements altogether. They forget about that phase completely because they're not asking you about what you want. If you did that, then everybody in the market would have this particular feature. They would have the software. So this particular technique allows them to put something out quickly, get it out, be first one out, get users bought into it, and then make it into something that's really good, like Gmail or Google Docs or something. Eventually what ends up happening, as I saw last week when I was showing you the models and the evolutionary development, we have version 1, we have version 2. Once we decide we want version 1 of this, then we go back and build it for reals and come up with a stable version of it, replace the prototype with the stable version. So you're still building a system, but you're using the prototyping to elicit the requirements while the system's being used. You know, if that makes any sense. You put it out there, you have people using it, and you're changing the requirements, and then eventually you're putting out a full version of it that's done. It already incorporates all the other requirements. Because what ends up happening with rapid application development is that it's rapid, hence the name, and not necessarily done according to spec standard. It's hacked. It's a prototype. So you got to go back and fix things. And people usually start from the ground up, design the thing, build a stable version of it after they've already collected all of their requirements. So a lot of apps for the iPhone, a lot of apps for the Google Android environment are done this way. And you'll see that's why there's so many updates. Well, there's an update to this, there's an update to that, because it's a prototype that you're using that's evolving into the product. So, and usually one or two of those updates are significant because it's replacing your entire system with a different app, with a real one. So, but yeah, that's the more current approach. And obviously, you could probably tell that people aren't going to wait a year and a half to put out Gmail. They want to put it out quickly. That's why they made it. That's why it's popular. So they were the first to market in a very high competitive type of environment, which is why your high-tech companies are doing it that way. If you think about it, I don't know if you guys saw that Facebook movie, the Social Network. That was a prototype. He had that thing out instantly, and then the first version of it, second version of it, third version, it's still being changed. It's still being worked on. It's still evolving. So that type of product actually never finishes, which is one of the problems with that. So it's great because you get it out first. It's bad because you never have feature lock. It's never really done. It might be obsolete before it's actually completed. And then it runs buggy for way too long. So somebody else takes a look at it and goes, ooh, good. Which is kind of like what the LinkedIn people sort of did. They went, oh, let's build a better system. Now that we have the requirements, now that we have everything we need, let's build it more efficiently from the ground up, make it more sophisticated, and make it easier, and integrate a lot of stuff in there that is not normally integrated in other types of social applications and stuff. So it gives you the ability to kind of mess around with different options and do it professionally instead of rapidly. So, not to say that I don't know, Facebook's really still pretty popular. So I think eventually, though, something's going to replace it, though. That's what I suspect. But think about it. These people that are going to replace it have spent years working on it already. They just haven't released it yet. So, well, why compete with something like Facebook anyway? And if you follow the history, wasn't MySpace extremely popular? And then Facebook comes out, and everyone runs from MySpace and goes to Facebook? So you're going to be running from Facebook and going somewhere else soon. That's just the evolution. Hopefully not too soon, because it's pretty good. All right, so gathering and analyzing the requirements, we have what's called use case analysis as well. So we determine the classes of the users and the actors of the users, and we determine the tasks that the users need to perform to make the system work. And we come up with what's called use case scenarios. If we do that, and I'll have more on that later in the course, but if we do that, and then we can actually look at and design the user interface and then build it from like a top-down perspective. So we need a login screen. And so we have an actor who's using the system to log in. We need an accounts payable. We need an accounts receivable. We need a reports module. And we map it all out in terms of which is probably what you're going to end up doing when you develop yours. You're not going to be writing use cases, but you'll be doing it later on in the course when you start doing your analysis. But you'll be doing informal analysis in terms of uses. Because most people think of the system as in terms of how it's being used. What are we using the system for? And that's where you're coming up with the requirements. Now, I talked about different types of requirements in terms of functional and non-functional. There's also different types of requirements documents. We have a requirements document, which is a generic term that's sometimes, in my case, I'm using it as another term for definition, or we have requirements specification. So a definition and a specification are just different in terms of the level of detail. So we have many different audiences for all of these documents. The easiest one to put together is the definition, which is what you're writing. Definition is complete sentences that say, the login screen will come up after the splash screen. This will happen this, and that will happen when, blah, blah, blah. The specification is thousands of pages of intricate detail about every single one of the features about that login screen. You're not going to do that. If you did that, your requirements doc would be 100 pages long. You could spend 6 months writing that requirements doc. It's kind of like the differences between a repair manual and a specification manual. You know, the repair manual is going to tell you to change the oil. The specification manual is going to tell you all the little pieces of the engine that contain the oil and how the oil breaks down and how the dirt gets into the oil and all the little specs in terms of different grades of oils and everything you ever wanted to know about the oil or something. The development team sees that. Sometimes the specification is completely missed, not done at all. Sometimes both are being done. The end user sees the definition. Says, oh yeah, look, there's a login screen. There's a logout screen. There's a this, there's a that. And it's basically a high-level overview and paragraphs, simple diagrams, perhaps, of the system. You don't have to do any diagrams, by the way, for your requirements document. And then we have that long list of specifications that's used to give the developers more detail. If you show the specifications to the end user, they're going to look at that and go, oh, what, I don't understand this. I don't understand that. You know, it's too much detail. So just think of them as different levels of detail. So the levels of detail required in a requirements document. How much detail you provide might depend on, and here's the problem, because you're going to say, well, we have to write this requirements, and 9 times out of 10, the only concern is how many pages? I can't tell you how many pages. There's no minimum and no maximum number of pages, because it depends on the system you picked. In fact, people go, oh, I picked an easy system. Easy systems are hard to write requirements for. That's why I said last week, pick a hard system. Pick an extremely difficult system, because not difficult in terms of complexity, some cutting edge technology that doesn't exist, but something in terms of a big system, like a whole registration system, not just an add-drop system, because then you have more to write about. Because what's going to end up problem you're going to end up having is, when do I stop? And how do I know when I've reached a sufficient level? So it depends on the size of the system, the nature of the system, the need to interface to other systems naturally creates more requirements, because we have inputs and outputs to consider. The readership, the shorter the better. It's like, you guys know keep it short and simple? KISS method? Yeah. I think it was popular. Kiss method. People use it all over the place now. And it's like, kind of an overused word, but it does make sense in business terms. Software engineers are business people and they're software people. They're like both technical and business. So you can't write a spec and show it to a customer. They're not gonna like it. So the level of experience with the domain and the technology is also going to determine how long it is. If you're not familiar with RF technology, you're going to say, has to use RF technology. You're not going to say, must use RF technology of type 1.0 spec, IEEE space. Is that door locked? The guy's like standing at the door. No. I was concerned that the door was locked on you. This is software engineering if you want to join us.
Yep.
Okay.
That's true.
You are students, well then come on in, sit down. Not to point you out or anything. Maybe you put like a little schedule on the door, maybe? Let people know what's going on here. All right, so the cost that would incur if the requirements were faulty may also be a concern. As an example, going back to that heart monitor, if you didn't spec it out correctly, or it didn't work, then that might actually negate the entire expense and everything that you did for the project. You're going to end up in trouble with it. In terms of reviewing it, each individual requirement, this is the other part that's kind of complex. So you've decided you're going to have all these features, and then you start writing out the requirement statements, and then you figure out, well, I got more than one requirement in the statement. So you said the login screen must have a username and a password and use RSA authentication. Well, that's really 3 requirements, actually, all in one sentence. So you have to actually break it out and say it's going to have the login screen will have an entry for a username. The login screen will have an entry for a password. The login screen will have an entry for an RSA. The reason why you break it out is because we're going to do what's called traceability. You can trace the features of the requirements of what was specified to what was implemented and how it was done in the design document. So if you said one sentence that said we have a login name, a login password, and we have an RSA key fob entry code. And then in the design, you did the name and the password, but what you left out was the key fob. You might not be able to trace it accurately. So you're using it as a checklist. Oh yeah, login screen, name, password. Oh yeah. It's too easy to forget about the RSA key authentication or something, another component that was also encompassed in the entire paragraph or entire sentence. So you don't want paragraphs either. You want complete sentences, and the sentences might have a benefit and should have a benefit that outweighs the cost of the development, hopefully. Because here's what happens, people turn this requirements document into a wish list. Yeah, if you were a kid and you said, hey, we're going to go to the toy store, can you come up with a list of requirements for what you need from the toy store? It's like when we go to the grocery store. The requirements change when we get in there. Oh, look, they have this on. Oh, look, I forgot about this, I forgot about that. And then you walk out with 3 or 4 different shopping carts full of crap that you don't really need, didn't really even want. And then it burdens the whole load of, the whole drive home, and then half of it gets rotten in the refrigerator and you throw it away without even eating it because you bought too much or something, So you have to outweigh the benefit or the cost of it. It must be important for the solution of the current problem and not a future problem. That's the interesting thing, is people like to put features in the requirements doc that they have no intention of building. And then you look at the requirements and you go, well, we didn't do it. Because we have this thing called validation and verification that we'll be doing in testing. And you can't, both of them fail if you have features in there that don't belong. They aren't supposed to be part of the system. You also want to make sure you're clear and concise in terms of its notation, unambiguous. You must have a login screen. That's a little ambiguous, believe it or not. What's on the login screen? What kind of login screen? Login to what? Logically consistent. So section 1 says login screen, right? Section 5 says, ease of use. No login screens anywhere. No. So one part of the document you said everything has a login screen. The other part you said nothing has a login screen. And then now what ends up happening is this is your contract. This is what you're building. It's like impossible to build it this way. It's not feasible. Lead to a system of sufficient quality, perhaps, hopefully. Be realistic, verifiable, and identifiable, and does not over-constrain the design. So do we all know the difference between verifiability and validity? So, actually, raise a hand. We know the difference between validation and verification? You were in software engineering too? No, we weren't. So to verify a feature means you've implemented it, you've traced it, which is how traceability works. So in the design, you can have a check-off list. It's kind of like when you buy a car. You probably never bought a car. You buy a car, you have a check-off. No, okay. You get something done, a repair done, and the guy comes over and says, okay, I'm done with my repair. Okay. He comes over and he says, see, look, I loosened up that rope, and I put in a screw, and I put in rubber hose here, and he's pointing out all the things he did to fix the problem. He's verifying that he has implemented what you have required him to do. So he's gone back to the requirements doc and said, you need to take out the rope, you need to take off the duct tape, put in a rope pipe, put in 2 screws, and make sure the water flows through correctly. And so he can go through and verify that he's done what you've asked him to do, and that's your requirements document that was implemented in the design, if you're relating this to software engineering. And you have this verification. Yes, I have verified that I've implemented everything. And then you can validate it. Is this a valid solution to the problem? Well, the hose is too small. The water doesn't go through and it backs up into the sink. Not a valid solution. So it can be verifiable. Look, I've done everything you told me to do, but you didn't spec out how wide you wanted the hose. You just said put a hose in there. I put an itsy bitsy little one that the dentists use, instead of the ones they use for plumbing or something. And no, I verified, I've done it correctly, but it's not a valid solution to the problem. So there's no validation, and you have to go back and have the project done again. It doesn't work, but it verifies out correctly. And then you have to figure out, well, who did what. So in the requirements, you make it verifiable, which means you have to verify, did you put a hose in? If you just said, yes, I put a hose in, the requirement's wrong. Because the requirement for the hose should have said you have to put in a 3/4 inch diameter hose. That's why you see requirements documents that are way specific. 1 inch wide plywood boards with 2-inch nails or something. You must do this, you must do, and it all specs out sizes of things, shapes of things. Everything is specced out so it's verifiable. Because if it's verifiable, hopefully it's going to lead to a valid solution. You're going to have validity on the solution of the problem. So, and here's that concept of traceability that I'm talking about. This is the kind of the slide that goes along with that concept. Documents should be sufficiently complete, well organized, agreed upon by all stakeholders, and then we have the rationale. So in the requirements document, feature number 1.1.xx, whatever, that says what we wanted implemented. In the design document, we have, due to this requirement, we've done this. Due to that requirement, we've done this. We can actually number them correctly and correspondingly. So we have the requirement 1.2, which goes around with 1.2 here. We can use numbering to do that. Or we could actually specifically refer to the requirements numbers in new numberings. So the numbers aren't the same, but the flow of the document indicates which requirement we've implemented. That way we can say, yes, we put the hose in, we put the 2 clamps in, in our design, it's called traceability. And we can trace it back to the requirements. And it gives us verifiable, makes it verifiable. So if you just showed me a design and say, look, it's written in Java. This is all the specs for it. But where are my features? You can't verify that anything's actually implemented correctly. So if you could do that in the documents, what you do is you take the document out, and I'm going back here for a second. You can outsource this easily. Because this is the template. This is the blueprint to be outsourced. Kind of like building a house when you've got your architectural design, you got your blueprints, you got everything you need. And you send that out for 3 quotes from construction companies. And they come back and say, hey, we'll build it for $10,000, we'll build it for $20,000, and you pick the one you like the best. It's not always associated with the cost, by the way. Sometimes it's reputation, quality. And have they really understood the design? And do they know what they're talking about? Because some people don't even read it. They just go, oh, you want a house built? Ah, $10,000. People do that with software all the time, actually. Nice game to play is go get one of these outsourcing companies online. Just put a little short description. They come back, oh, $10,000. Yeah, where'd you get that from? How do you even know what I wanted? I didn't even tell you how many features I want in this thing. How do you know it's $10,000? Then you know the company's going to screw you over in the end. It's not going to work. So let's go back to the requirements doc, and I told you before I'm going to flip through another example of it so you can see what you're building. We've got a problem in section 1. We got the background information. We could go with the environment and the system tools. We could go with functional requirements. We could go with non-functional requirements. That's what I basically, for those of you who came in late, you don't know what I meant by that, but that's the beginner's approach. Our template that's on page 25 of the course notes is going to have a slightly different template to it, and I'll wait till I'm all done to bring that back up to refresh your memories on what it is that you need to do. But in terms of requirements, what ends up happening is we have to manage changes as well. So we come out with a perfect document. It's kind of like when you write a thesis paper or an essay. It's perfect. And then you go to bed and wake up the next morning and start reading it. Oh, I was tired. I don't know what happened with that. That's because your memory changed and all of a sudden your opinion of the document changed. In the real world with software, nothing stays still. The company is still working. People are still doing their jobs. The environment's changing. They might change because business processes or technology is changing. So what ends up happening with the particular software engineering changes is it happens a couple months after the project already started. You've already got your requirements. Now there's a new tax law. Now there's a new regulation of something. And the problem becomes better understood as well. So you came up with your requirements here. You made your design document, and now you figured out, oh, I left out some requirements. You're going to leave requirements out. Or you're going to go, oh man, now I understand what they wanted. I didn't understand before, but now I understand it. what do you do? So that's where we have differences in those different models that I talked about last week. So there's no cookie cutter template that you can use, and there's no surefire way of making sure your requirements are good. So you have to actually kind of review and send feedback up. And this is where the feedback comes into that waterfall model that I showed you last week. So learning outcomes from the analysis from the design should go back up, and you should modify the requirements at that point. And if they're major modifications, you have to decide who's going to eat the expense. Because the requirements is generally your contract with the customer. And so this is what we're going to build, and this is what it's going to cost. Oh, I forgot. We have a database. Oof. The database software package is going to cost $10,000, or it's going to take another extra week. Then you have to go back and say, hey, we forgot about this. And a good software engineering company will just be honest with you and say, hey, we forgot about this. Do you want me to put it in here? You want me to put it in here? I'll cut the cost with you. You pay $5,000, I'll pay $5,000. We'll put it in, and it's going to be late. I'm not going to be able to meet your deadline. It's going to be 2 weeks. Oh, okay. The bad software engineering company will ship it without the database and blame it on the customer and say, hey, you know what, you didn't ask for it. Or wait until the very last week before the project is actually due. And say, hey, guess what? You made a mistake when you told us what you wanted. We put it all together and it didn't work. But you knew about it. You knew about it months prior when you designed it because you figured out you left it out. So that's where problems with outsourcing actually come into play. Think of the concept. This is why it kind of failed in the U.S. U.S. companies are coming up with these requirements. They're coming up with the analysis. Some of them are even doing the design. But how do you really know it's going to work until you implement it? So you send it off like it's a no-brainer, and you get back something that's totally wrong, but it meets the requirements correctly. But there's no communication because when they started implementing it, they went, there's no database. I guess we put it all in text files. And they made decisions. And their decisions may not necessarily have been the same decisions that the people that ordered the software would have made. And there's a lack of communication. So you spend money on someone who sits in between and micromanages the project, who takes the information. Say, hey, look, we're missing the database. Goes back to the customer, hey, they're missing the database. And negotiates back and forth. Or it's somebody who contracted that outsourced company who's supposed to take the initiative to go back and forth. And that ends up costing you more money than if you just built it yourself. So a lot of that stuff's moved back into the States, and now we have tighter control over it. And we don't have to worry about all of the communication channels. And it's not an English thing. You guys know where it's all being outsourced to. They know English. Little bits and pieces, just enough to get it done. So it's not necessarily a fault on either end. It's the channel. It's the way that it's set up. If you don't manage the process correctly, you end up with serious issues, and it doesn't work out. And it costs U.S. companies more than if they just hired an engineer. So there's not a lot of programming jobs coming back to the States because tighter control, more communication going on. It's right here. It's not over there. All right, so requirements never stop. You continue to interact with the client and the users. The benefits might outweigh the costs, hopefully. Quick, small changes are good. They can be made. In fact, small changes are encouraged because you're better suiting the needs. Larger scale changes must be carefully assessed and make sure that they're not, if they're large and they're not natural part of the first version, then they might end up with an upgrade. So then you can sell them on a brand new system. Say, hey, we can make you another one that uses the database. Version 2. Version 1 doesn't, but version 2 does, or something. So you can sell it that way. And some changes are enhancements in disguise. So they say, hey, can you make this work on so you made an iPhone app for your registration system, and you go, oh, can you make this work on an Android too? And then all of a sudden it's like, oh yeah, and then some overzealous person on the team says, oh yeah, we can do that. And you end up building 2 systems instead of 1 system, 2 different platforms. Ends up twice as much work, but you only get paid for 1 because you added it, but it wasn't really part of the project. It was an enhancement. Avoid making the system bigger, only make it better. So don't add features. So another common problem, which is referred to as the scope creep that I talked about at the beginning of this lecture, and those are adding features. You're supposed to be making it better, not adding functionality. So You add functionality to make it work if you've left off the functionality to begin with. But if you didn't leave it out, then you're not supposed to be adding it. It's not a mistake. So that's where the negotiation, that's why I say software engineering people, especially ones working with requirements, need to be business people. Because you have to negotiate with the customer and say, hey, you know what? The wireless part of this, you said wired. Remember to put the wireless stuff in there? We've got to do so much more testing, so much more design work. And it's this different system. You wanted a wired system. So difficulties and risk in the domain and in the requirements analysis. So now I told you everything, I gave you a few problems that could go wrong, but everything sounded pretty positive, straightforward, and easy to do. Not so real, not so true in the real world. In terms of some major categories of areas, there might be a lack of understanding of the real problem, which is the biggest thing, especially if you're using cutting-edge technology. You might not know that you can't use RF, point to point with across a city. Not going to work, maybe. If you don't know anything about the technology, you might not necessarily realize that. Or you can't use wireless in a brick building or something. That might be an issue. Or there may not be any domain analysis done. You may not have consulted with a network specialist, but you're building a network application. And or maybe perhaps no prototyping was done. You built the system without showing them what they actually asked for because it was ridiculous. This foot control device was 2 feet off the ground. Caused leg cramping instead of carpal tunnel now or something. Maybe the requirements are changing too rapidly. That's what you end up having with, let's say, for example, the Gmail app, which is why you can't follow through with a formal requirements spec. Man, they're going to change. Every 5 minutes there's something new on the internet. There's new features, new capabilities, new something that's going to change. It's kind of like Facebook, actually. You have to adapt with what users want, how users are using it. You can't do that with the formal requirements. You may also be attempting to do too much. Actually, I think that's probably what ended up happening with the EMS at this university. Put it out, make it overnight. It's still not out yet because they've taken a big problem and they've tried to implement it all at once. Instead of just focusing on different concentrations of it, version 1, version 2, version 3, I keep adding functionality incrementally to make the big picture instead of starting out with the big picture, which is a common thing that people like to do. It may be hard to reconcile conflicting sets of requirements as well, especially when it says, we want passwords on everything, and there's part no, we don't want passwords on anything. It might be hard to decide, well, which ones do we want passwords on? And it might also be hard to state the requirements precisely in terms of what IEEE version of this protocol did you want me to use? And maybe they don't know anything about the protocol versions or something. They didn't state it precisely. So, and here's how the requirements process should work in a real business or a company. You're going to put together a requirements document, generic form of the requirements. If you were working in a real software development company doing a real 2-year project, you would start out and you would actually do the feasibility study and you'd come out with a feasibility report and it would get sent off to the management people and they'd look at that and go, oh, wow, let's build it. Or, no, this is not really good this year, let's wait till next year. So they time it out, they plan, and then they decide, let's build it. Let's say, for example, and this is how the arrows are going. Then you come out and you do requirements analysis. That's when you're going out, observing, you're setting out the surveys, you're figuring out what features you're going to want to put into this thing. You might actually put together the system models, and system models might be the prototypes. System models may also be paper-based. If you walk into some of these development companies, it's usually on the walls. And it's usually operations departments that love to do that, or manufacturing facilities. You have the entire manufacturing plant route, construction part of it, all laid out. Or you have the operations flowed out where sales and marketing are communicating. Because pictures say 1,000 words. System models help you. After you've done the system modeling, you're really coming out with the first version of the requirements document, which is what you're supposed to be doing. But you don't have to put together system models or prototypes or anything like that in the beginning. And then the requirements analysis, this kind of flows this way a bit. but then it also goes back here, and the definitions comes, and after you've defined things, you go back and you do some more analysis, and come up with more definitions. And then the definitions actually turn into the requirements. So those actually, the definitions of the requirements come out, and they come into this deliverable here. And I'm calling it could be requirements definition, or it could be called requirements document. You look at a textbook, it's always called definitions. And then I realize it's usually called document. Software, it's an SRD, software requirements document. But then you also have software specifications, or an SRS, software requirements and specifications, which confuses people. And what you've done here at this point, you can stop. This is what you're giving the user, and the person who's asked for the project. You're giving them this requirements document, and you're going back to the stakeholders and saying, this is what we're going to build. It's all saying what. And then at the same time, if you're going to take it a next step further and you really want a solid development product, then you go and you do the requirements specification. The requirement specification is just another tacked on. You can kind of see it's over here to the right, just kind of hanging there. It might be left out. You're going to leave it out, actually. But if you're building a heart monitor, you're building a mission critical satellite or something, you're building something that is going to take more than a year or two to build, and you want to make sure it's correct, then you're going to do the specification. That's going to be part of what it is you're going to want to do. Otherwise, it leaves too much ambiguity, too much unknown in terms of development. So in terms of the requirement specification, what is the purpose of the requirement specification? The purpose for you in this class is to define what you're going to build. In the real world, it describes the requirements to the shareholders. After you put it together, you'd actually take it over. You don't have to do it for me because I'm just going to read it. But you take it back to the customer, set up a meeting, and you go over it. And then that's the starting point for the contract. So it expresses the terms so that they understand, hopefully. The document is comprehensible from many different viewpoints, hopefully, especially if you have some system models. So what ends up happening is people put together the requirements document, then they create some system models, pictures. They go, hey, look, they look at the pictures. The customers look at the pictures and they go, what is that feature? And then you go back to requirements document, and that feature is and you give them all the details on it. So the picture is easier for them to understand. Not to say that end users are stupid, but they're not getting paid for this. They asked you to build something. They're gonna give you 5 minutes of their time, hopefully, and then you're gonna have to explain everything to them that you're doing, hopefully. And you have to do this because you have to understand that you understood what they actually asked you to do. If you don't verify that, you're off on the wrong track to begin with. And a lot of companies don't do that. They assume that they've understood everything correctly without verifying it. So you review the stakeholders so that they understand the implications of anything must be clear, but assumptions, things may be left out of the requirements, and they figure that out. Oh, what about this screen? What about that screen? It also describes requirements to the implementers. So the other group is the people who are building this. Because those requirements people, they go away and they work on the next project. So you can work as a domain analyst. You could work as a systems analyst. You could work as a business analyst. All these people put together requirements documents. They don't actually build the software. It's a totally different group of people that design it, totally different group that build it. So, you go on the next one. So you're done. You move on to the next project. And so the implementers are looking at this design through the requirements that you've left them, their little keepsake that they get. And then they look at that, and then they start building it. Another group comes in and says, well, let's analyze these requirements and let's build a design for it. That's why the document has to be complete with no assumptions, because it's a different group that's working on it. A different group that does the maintenance as well. And the maintenance people have to come back and say, well, how was this thing built? This is the artifacts that are left behind. And say, here was the requirements document. Here was the analysis that was done. Here's the design documents. This is all the information you need to maintain the system, to build a patch for it, to do everything for it. You have all of the documentation. You don't have to bug anybody. So you can't go back in and ask people, you got your first job after you graduated, you're probably a maintenance engineer. You answered the want ad, you came in, yeah, can you work on this? Sure, then they get, here you go, build an upgrade for this to include a new screen. You're like, well, I don't know anything about this system. You know, somebody else wrote this system. You know, then you have to go back through all these documents, and this is what they give you. Here's the requirements. Here's the design. Here's the source code. Have at it. Like, so it depends on the quality of this stuff as to how easy it is for that maintainer to do it. And so it has to be precise, specific as possible, expressed in terms that they understand, comprehensible to new team members, because this affects how fast your team gets up to speed. Because nobody's job is that important these days. In the old days, before we had this process, especially here in the States, if you were a programmer and you got on, you never documented anything, you were like for life. They couldn't afford to get rid of you. Can you imagine what would happen if they fired you? They wouldn't know anything about the system. They didn't have any documentation. They had nothing, and you barely documented the code internally. Now if you do that, you'll get fired. But in the old days, people did that because it brought them job security. And the business people don't know any difference. You know, oh, here it is, it works. You have to keep me on for life so I can support it. Now, totally different people write the software, totally different people design the software, totally different people maintain the software. And this is the foundation. This is the documentation, and the process of the development is what keeps it all together, theoretically. So it's all in the quality of the development effort. And it records the requirements for the future. That's the point I just mentioned. And it's essential for system evolution. You don't record it, you can't evolve it. And it may be a contractual document to see you in court. You didn't build it, I'm not paying for it. So you're not going to get anything, essentially. Because, you know, hopefully the project team hasn't gone out and installed it, and then they sent you a 30-day bill in the mail. And you say, well, if it doesn't do this, I'm not paying you at all. And then they go to court and win, because it doesn't do this. You know, if you bought a pair of scissors and it didn't, you bought a pair of scissors to cut cardboard, and it only cut paper and didn't cut cardboard, are you required to pay for it? In this country, no. Usually you're required to return it for a refund, but how are you going to return software? How are you going to return a 1.5 year work of effort that a development team has done? You can't do that. That's the problem. That's why software is so volatile. You know, like companies come and go because either they spent too much money and didn't deliver, or they delivered the wrong product, never got paid, and so you worked for a 1.5 years, 2 years without anything. So, all right. So the project work scope, your project topic and requirements. Begin formulating a list of requirements, and as promised, we're going to go back and take a couple of minutes. We're almost done. The software engineering notes on page 25. And take a look at this requirements document one more time, because the next lecture I'm going to move on to analysis. So today we're talked about requirements, if you came in late. So on page 25, let's take a look at this here. Make it a little bigger. I know you can't read most of it on the screen anyway. Let's see. There we go. Much better. I'm going to try to see if I could go. Pages. Oh, no, it didn't. Maybe there was a page down. That didn't work. Okay, 1 second. I should probably put this in a PDF file, then I can just go to page numbers. If you're not familiar, this document came from the bayhacker.com website. It's called Course Notes, right underneath the syllabus. It's your reading material for the course. Page 25, and each one of the templates for each one of the deliverables that I've been talking about are in this document. And page 25, we have the template for the requirement specification document. And you might notice I said it wrong already. It's requirements document, not specification. You're creating an SRD. So now you know what the differences are, hopefully, between an SRD and an SRS. So you can go out in the real world and go, is this a SRD or an SRS? And then you'll see they label them incorrectly most of the time. Most people call this an SRS. This is not an SRS. It's too broad. It's not specific enough. And it's only like 3 pages long. So let's go back, and you can kind of put the lecture material into perspective and see a real example here. This is a real example. This is an upgrade. So this was requirements were already provided by the end user, and it was an evolution to an existing system. So the focus is going to be different than your projects. Your project, if you can remember that little quadrant I showed you with A, B, C, and D in it, template, and slide number 2 or 3 if you missed the beginning of this. The source for your project is a brand new set of requirements. They didn't give you requirements. And you're probably not going to build an upgrade. If you do build an upgrade, it might be similar to this then. If not, you're building a brand new system. It's going to be a slightly different focus. Now, I'm going to give you some pointers as to what the differences are in terms of that. Every one of your documents is going to have a scope. As I mentioned before, we have to have a scope. And that's what the document's all about. So this SRD covers those requirements pertaining to the interface, internal operation, and the reporting functions of the XYZ program. I took out the name of the program and I put XYZ in there. So this is an upgrade, and it's covering interface, the interface, user interface, internal operation, and reporting functions. Only 3 areas of functionality. So here's where you're defining what you're building. So you might say, I'm building a student registration system that's going to cover registration, adding, dropping, and paying fees. And then that's all you have to scope out. So if it's anything related to financial support, financial aid, does not belong in this requirements document. So the scope is your contract for what you're building. And then number 1.1, I should change this actually and make it, because we don't have 1.0 of anything anyway. But this really isn't 1.0. This is like 2 point something. You could do it. You could put this in, or you could leave this out on your documents. For this particular example, and just to give you, if you wanted to put it in, the identification, the document covers 1.0 of XYZ program. At this time, a formal name has not been identified for the program module. So it's 1.0 of a program module, which is why the numbering was used for 1. This module doesn't exist. But the program module is for an existing system. And we're calling it XYZ. Or whatever. You may or may not put in an identification on there. The identification is actually used for version control. And I'm going to talk about that later in the course. But showing you as an example, in this particular case, you might have different versions of this requirement spec. You might have one version that has these 3 features, another version that has 4, or one that has 2, or one that has 1. Because then you have choices, alternatives. And maybe the customer only has $10,000. And so if this one's $10,000. If you can come up with an extra $5,000, this one's $15,000. You can use them different pricing scales, different feature lists. So the versioning helps you identify. And if you put the identification in there, it's kind of like self-documenting source code, or internally documenting source code. All right, so section 1.2, we got the system overview. This is a brief description of what it is you're talking about, what it is you're building, not the scope. The scope and the system overview are 2 different things. The scope is identifying what you're building. The system overview, as this goes, is giving you a textual description. Like, this is an accounting program. This is, well, what is this? This program is designed to provide DAP personnel managers and software developers with a means to ascertain if specific address records are contained in XYZ. See, the scope is different from the overall system description. Some people, I have seen this before, they give me the same thing. Or they call it scope and overview, and it's the same paragraph. It's like, no, you're telling me what kind of system this is. It gives me a better understanding. Oh, I didn't know this provided DAP personnel and managers with these features. Okay, you may not necessarily have any reference documents. This one doesn't have any. You could leave it in, you could leave it out. If it says none or an unknown, if you think you're going to maybe put them in at a future time, you can leave placeholders. But you don't necessarily have to have that. And then we have number 3, the lo and behold, the requirements. You can call it general requirements. In this particular case, it's broken out. Notice the numbering. I'm really bad because I didn't indent it. You can add indentation that looks like an outline. It makes it a little easier. Adds to the readability, but you don't have to. You can put it all in the left margin if you want, which is how this is. So because I have requirements I'm going to have general requirements, or I could just say general. And then down here, version 3.2, I have user interface requirements for the parameter settings. And then 3.3, I've got user interface requirements, but this is refreshing directories. And then I've got 3.4, the address record lookup functions. And don't be concerned about understanding these requirements. They're specific towards this application. But what I've done is I've taken the application, as what I mentioned prior when I was talking about the lecture material, I've taken the application that we're envisioning that we're going to build, and I've broken it out into functionality. Don't take the functional, non-functional. This is easier. This is actually easier. And I'm not going to go through each one of the sections, because at this point you're looking at, well, if I wanted to understand this particular system, it might be relevant. But at this point, what you want to get is what should you write in the document. And here's a classic mistake that users do when they see this template. They start speccing out things like programming languages and platforms. This is an upgrade. This is an evolution of a system. This is a module that works. If I wrote this module in Java, I have a problem. Because this program that this module works in is probably on a 32-bit Windows system. That's what I'm thinking. And it's probably written in Visual C++. So as a general requirement for this module that we're writing for this existing program, the program shall be developed in a 32-bit Windows application using Visual C++ 6.0. Yeah, 6.0 is not current. Great. Because you can't write it in .NET. Not going to work. Especially because it requires a .NET platform to be installed. But we have a 32-bit window, probably an old version of Windows running. And if we want this module to work with this existing program that we're creating the requirements for, we have to use that programming language. Your program, I wouldn't put that in there unless you're building an upgrade to something. I'd leave it out. Because all you're doing right now is saying what you want to implement. You specify the how in the design document. So just because you didn't mention it here doesn't mean it's not going to be mentioned. So if this wasn't an upgrade, in the design, after I've done my analysis of the program, in my design I'd say, let's do it in Java, or let's do it in .NET. Or I would pick out, I'd say how I want it implemented in the design. And here I want to say what. But unfortunately, I'm stuck with a 32-bit. So if I said this in here and this wasn't an upgrade, people look at this, I give this to the designers and they go, what? This hasn't been around since like 1990, whatever. How am I going to build this thing? It's not going to work. And then they have problems. It's overly constrained. But I see it all the time. We put in here, I must work with Oracle. I'm wondering, well, why Oracle? What if the company already owns and has installed MySQL on their server? Why can't they use MySQL for it? You're just adding expense. We're going to go out and install another database? So think generic when you do the requirements, and don't say how, but say what you want implemented, but don't say how. I need a database. That's what you need. We want it implemented in Oracle. That's how. We want it implemented in SQL Server. That goes for the design. The program architecture shall support the multiple document interface metaphor. That's a requirement. You don't have to worry about what the metaphors are and stuff like that, but yeah. And if you go through, you'll kind of see another interesting example in these two requirements under the user interface parameter settings. We have screenshots. We're not putting the screenshots in here. We're saying, look at the property sheet that is available in appendix labeled screenshot number 1. I'm reading the last sentence of this. And it says, the network property sheet tab shall have blah, blah, blah on it. An example of the type of property tab is available in appendix labeled screenshot number 2. And then what ends up happening is down here at the end, we have our appendix. Way down here at the end, and we have, here's our appendix, section 5, and we have screenshot number 1, screenshot number 2, screenshot number 3. You don't have screenshots of a program that doesn't exist because you don't have property tabs that are created. Although I have seen this before. I have people who write screenshots and give me screenshots. The program that doesn't exist. You don't have to put screenshots in your program. This is why I'm going over this another time, because it hopefully will answer some of the obvious questions or that don't seem so obvious right now. Let's see. So we've got our screenshots, we've got our sections. We have sections, and this one doesn't have to do with any of the user interfaces. It's the address record lookup functions that are going to have, and it's going to read like Greek. It's going to be, program shall specify you're looking for a FOB, ROB, whatever, reports. You can use jargon like that, because what you can do then at the end is have explanations. You could have notes. Here we have some notes. Includes acronyms, abbreviations, terms, definitions. So you don't have to spell out a huge, so you can say EMS. The EMS will have this. What is it? Education Management System. And you can have like a whole list of acronyms and a whole list of stuff at the end. So you have notes, appendixes, and things. Because what you want to do is make this as simple and as straightforward as possible and as detailed as possible without having to redefine terms over and over again. Just use the terms. And then at the end, people know, oh, no, look at the notes. Maybe the first time you use it, or maybe at the beginning, you could say, see notes for acronym definitions. And then the user, oh, okay, flip to the back. There's notes back here. Or you can just leave it out and let the user figure that out. But what you're doing when you do that is you're adding to the readability of the document. Because once you know what the acronyms mean, you don't have to, every time you read, because here's what happens. The document is read over and over and over again. And you know how it's like when you write a paper and you put too much garbage in it? It's defined everything. Do you really want to read those definitions all over again? You're just trying to get to the meat of what it is you're looking for. So you put the meat in there, you put all the definitions at the end. It makes it so when you go back, you already know what they are. Just read it again. So it makes it easier for subsequent reads, is what that does. And the rest of this is, there's some packaging requirements. You might not have any packaging requirements. Who has packaging requirements these days? You put it in the iTunes store. You put it in the Android market. There's no packaging involved. There's no Seymour CD-ROMs or anything. That's old. This needed it to be on a CD-ROM because maybe the machine only had a CD-ROM on it. Maybe there was no internet access to the machine at that time, I suspect. Maybe there's a precedence or criticality of requirement section. Maybe there isn't. So not all of these sections are going to apply. So once we hit number 3, when you say requirements, that's where everybody's requirement spec is going to be different. And I don't care how many pages this particular requirement spec is. All right, so that's pretty much what I wanted to cover today. We have gone over a thorough kind of analysis of requirements. I'm going to talk a little bit more about requirements next week, but I'm going to hit requirements and go into analysis. So for those of you who just showed up, we're actually ending. But what you want to get from right now in terms of your progress through the course, because we don't have any assignments or anything, we just have this big, huge project to work on, and you don't want to wait till the last week. So if you haven't had a group yet, you might want to take a few minutes before you rush out the door. See if you can establish a group, at least, if you haven't gotten it yet. And when you do that, decide on a topic. And then if you have 5 people in the group, we're going to have 4 deliverables. We're going to have a requirements document that I just showed you. We're going to have an analysis document. We're going to have a design document. And we're going to have a prototype. You could split out all 4 to all 4 people and have one person work on everything. You could ultimately decide as a group you want to do the whole thing and everyone work on everything together. Or you can do any combination of anything you want. One person can write the whole thing if you want. However, that's a lot of work for one person, and if I were that one person, I'd rather work alone if that were the case. And I'll tell you, a lot of people are hesitant about using different people, and everybody wants to be involved. But in the real world, what ends up happening is you've got a team put together of 4 engineers. One guy does the requirements, and one guy does the analysis, one guy does the programming. Not everybody does the same thing because everyone has different talents. Unfortunately for you, or unfortunately, is that you don't know what everybody's talents are. So you didn't hire them. You just met them. So, and you're going to learn what their talents are, and you're not going to like probably, what you find out maybe, or maybe you're going to be like, oh man, I thought this guy knew what he was doing. He didn't do anything. And the documents, unfortunately, flow together. Like, the requirements has to be done before you can do the analysis. The analysis needs to be done before you can do the design document. So that's what actually makes this class kind of interesting if you are working in a group. You actually kind of have to coordinate, and then you realize, oh, project planning. Oh, all the other things that are associated with working with groups and people. And then imagine in the real world you actually work with remote teams. So the engineer is in China, and you're in California. So you have to use like email and Skype and stuff to go back and forth. So, which hopefully you'll get some sort of realization that it's not quite so easy. And of course, maybe your project will go perfectly fine now. All right, so we're done. We are completely done for today. So I'll see you next week. And for those of you who just came in, the class actually starts at 11 on Wednesdays. All right, ciao. See you next week.